In this video, we're going to talk about intraphrasal looping. So we're going to cover intraphrasal looping using the chop and Fibonacci transition methods, which have been talked about in other tutorials. We're also going to talk about creating the original rhythm sequence palette and using the chop method to chop that, and then how to assemble the rhythm sequence map from the rhythm sequences that we've chopped by using both Fibonacci transitions to collect the rhythm sequence chops and also the rebar method to recombine these sequences into larger bars. So first of all, let's talk about combining chop with Fibonacci transitions. What we would do first of all here is create an original rhythm sequence palette and then create a chopped version of this. And then we would use Fibonacci transitions in the rhythm sequence map to gradually progress through the specified fragments. This creates the intraphrasal looping. At the end, we would use the rebar method to make longer bars out of the generated shorter ones, because most of these chops result in very, very short bars. So if we look at the example here, we can see first of all that we're going to declare a variable num_seq. This is the number of rhythm sequences we're going to have in our piece. And we hard code this at the top so we can use it below. We're going to have 971 of these rhythm sequences. Then we've got our original palette, which is made up of 3 rhythm sequences, 1, 2, and 3. We immediately chop that using the given chop points and using the 16th note as a chopping unit. Then we call make slippery chicken with the following data. We have a tempo map, which is nothing new, an ensemble using 3 instruments, flute, oboe, and clarinet. And then we have a hard-coded or hand-coded set palette of 11 sets. What we then do is create a Fibonacci transition through those 11 sets. And again, we see here our backquote comma notation to splice in the result of a list into our set map. This is to avoid hard coding the transition. So this is an example of actual algorithmic development here rather than declarative development of musical structure. The rhythm sequence palette is, of course, our chopped palette. The most interesting point for us here, though, is our rhythm sequence map. And you can see, of course, as usual, we've got one entry for each of the flute, oboe, and clarinet, and they all look fairly similar. They're going to splice in with our backquote and comma notation the result of a Fibonacci transitions call. Just as with the set map, the first argument, the number of results that we want in this call, is going to be our num_seq variable, which was declared above to be 971. The second argument to this Fibonacci transitions call, in the case of the rhythm sequence map, is a loop from 1 to 30, because our chopping of our original rhythm sequence palette produces 30 chops, and we want a Fibonacci transition over those 30 chops. So that's created our rhythm sequence map. So all we have to do now is rebar these and aim for a minimum time signature of 4/4, which will hopefully be reflected in the output, which you can now see and hear.